Thank you very much. My name is Joel Hensley. I am an engineering director based out of our headquarters in Lincoln, Nebraska, so a little ways away, but happy to be here talking. So I'm going to spend some time talking about Hudl's first implementation of Redis, kind of walk you through the reasons why we chose Redis, talk you through how we got to production, how we're monitoring it, how it's performing, and then kind of the future of Redis at Hudl. So before I go, I just kind of want to give you guys an overview of Hudl as a company so you all understand. Our mission is simple. We want to help teams and athletes win. So if you're not familiar with Hudl, we're all about sports, the sports world. And so whether it's high schools, colleges, clubs, and youth, whether football, soccer, whatever, we really want to get to know the coaches and the athletes and help them be successful on the field. So how do we do that? It really comes to video. Video, we think, is at the core of really any kind of coaching sport you play. Video is the best way to be teachable and show people what they're doing right or wrong and learn from. And so we build apps. We have an iOS, we have an Android app. We build tools to help you capture and upload video right at the game, the gym, the court, wherever. We build apps to help you tag a game, add data, add stats, and then analyze it either during the game, after the game, and then really make it easy to share with anybody on your program or outside the program, whether it's because you want to do practice sessions or opponent scouts or exchange with somebody you're playing next week. All that's capable within Hudl, and that's kind of like what our core tools are really built around. So then the next part of our business has kind of grown in the last couple years. It's like our community features. So we've known for a while, we have this sports graph at Hudl that no other company really does. We have all these nodes with coaches and athletes who are on teams, who are on schools, who play games. We have all this data around stats that no one else has. And so we're trying to build a community to take advantage of that. And so we kind of break it down in 3 different areas. We want to help athletes get inspired through our content, get better to reach that next level, and then get noticed. So we have platforms to build profiles, make highlights, help kids, whether they're trying to get from JV to varsity, go to varsity to college, make that possible through our community features. So I mentioned this before. So Hudl originally started as a product focused on high school American football, and that's where most of our users are still at today. We've really grown quite a bit since then. We're at year 11 as a company, and we now have products geared for all sports at all levels. And so, you can talk about the younger generation of kids who are going to grow up with having literally a profile that's going to capture every moment they were on sports, from when they were 3rd grade kicking a soccer ball to when they are in the EPL, getting broadcast to millions of people around the world. Like, that'll all be in Hudl down the road. So really exciting stuff. So I mentioned the EPL. So we work with a lot of professional leagues. There's just a couple examples. EPL in UK, the NBA. We actually have both the Warriors and the Cavs within Hudl. So both way, we're happy whoever wins the finals. We have teams throughout Asia Pacific and New Zealand, Australia, and China. And then really, we kind of like work from the bottom up and top down in some places. And so by having these relationships with these professional leagues, it actually helps us gain penetration in lower markets like the club and the federation programs in other countries around the world. And so to give you some context of like kind of where we're at, how big we are, these are some raw numbers. It's always kind of fun to look at when American football starts up in the fall. So many coaches and athletes are downloading the Hudl app that we actually become, I think we usually get the top 5 of the free sports app on iPhone and Android. So it's pretty exciting to watch that trend up. We have quite a seasonal amount of traffic within Hudl too, because it is focused on sports. And so as a sport comes in season, doesn't really matter what sport it is, but you have practices leading up to that. You're going to have coaches and athletes logging in a lot more. It's going to get really crazy in the peak of season, and then once the season kind of dies down and the season's done, people are going to leave. And so that 3.75 million, it's going to really kind of go up and down throughout the year. And so we are going to be very bursty and heavy, especially in the fall weekends when we have that peak usage. And then the million monthly video views, so that's part of our community features. So we have many more billions of clips that they're watching within the game video. But this number is looking at that community features and how often people are sharing video with other friends and watching and taking advantage of that. And so that's kind of what my talk is going to be around today, is around our community feed and how we're using Redis to go through there. So to give you some context, I want to talk about where we were 2 years ago. So in 2015, Hudl had a feed, and I'm going to use quotes here, it's a feed. It was really unlike any feed you're used to nowadays. So what Hudl would do is, if you were an athlete on, say, the football team, and you also played on the basketball team, we would force feed content that we thought you wanted into your recent activity list. And so if a coach uploaded video, if a coach shared some notes, if one of your friends made a highlight video, that would all get sent to you, and you really had no control. Like maybe you liked it, maybe you didn't like it, we didn't really care. It's like, here, you can look at this, you can take advantage of it, but without the ability to follow other accounts, we really weren't a first-class social network at all. Like there was no way to curate that feed that you just come to expect. And so on the back end, the way it was working was, it was a fan out on read approach. So you would hit the homepage of Hudl, we would look to see what teams you're on. Each post would have different permissions set to them. So like if a coach wanted to send it to just the offensive line or just the athletes, we have to take into account those permission checks. We merge everything together, and then we would then cache that list of, say, the 20 most recent posts in Memcache. The thing that sucked about that was, let's say it's during season and a coach uploads like multiple videos back to back, or your friends are making highlights throughout the game or after the game. Whenever anything happened on a team, we had to then bust the cache for any user on those teams to invalidate the cache and guarantee that we would get a fresh data the next time they loaded it. And so it led to very low cache hit rates. And so it worked okay when we had lower number of users, but as Hudl kept growing, getting more users, we knew it wasn't going to scale and it was going to be a big performance hit down the road. So what did we do? So we took a step back and looked, and like, social networks are nothing new. They exist all over the place. The ability to curate your feed really is at the core component of that. And whether you call it like following, friending, subscribing, doesn't really matter. We knew we had to have it. And so we took a look at our database and made some changes. So the top two collections, users and content, those are always there. They were there before, made changes, just basic users and then pieces of content you want to share to somebody. The next layer here, this is where that curation comes into play. We really kind of follow suit of what the Twitter model looks like. It's a one-directional connection. So an example of like the NBA finals going on tonight. So let's say LeBron James wants to follow Steph Curry to get some tips on shooting the ball, whatever. So he would follow Steph Curry. That's going to create two records. LeBron James would be a follower of Steph Curry. Steph Curry would be a friend of LeBron James. And then that gets us a nice, easy way to get lists of all your followers and all your friends, depending on which way you want to look at it. And then so the next step down is the content. How do we display the content and do it performant? So we have two different timeline collections. So in our example before, so Steph Curry uploads a video of his pregame shoot around. That's going to go to the user timeline for him. And so that's going to be his history of all of his activity. Any posts he's done, it's going to be reverse chronological. It's what you see when you go to someone's profile on Twitter or Facebook, whatever. That's their user timeline. And then the home timeline is what everyone's used to seeing when they log into these applications on the main homepage. It's going to be your curated list of recent posts, people you follow. And so in this case of Steph Curry, he's a popular guy. He's going to have millions of followers. And so we're going to go through and we're going to fan out on write now, so not on read. We're going to fan out on write and post that link across all of his followers. And so if he has 2 million followers, it's going to create 2 million posts in the home timeline. But then now whenever LeBron James or someone else does a refresh or pull, we have all that content right away, and we don't have to build that on every request to view content. So let's take a look here at the architecture. I wanted to keep this pretty high level. I didn't really want to go into the super depth of how we have services and business logic laid out, but I want to focus mainly on kind of like the database and caching interactions here. So going back to our example of uploading a video, posting it to your followers, it's going to hit our API layer, and then it's going to fork. And then based on writes, we're going to go to the producer service, and reads are going to go to a consumer service. And so we wanted to have that separation to give us more control and flexibility of how we want to scale and partition those services. For instance, we've seen in our feed production environment, consumers are going to get way more traffic than producers. There's like probably 20 to 1 number of reads than there are to writes, and so we can scale that separately without impacting the producer service entirely. So it's going to come into the producer when he uploads the video. First thing we're going to do is we're going to queue that message. We take advantage of queuing really across the board at Hudl. It gets us a couple of niceties, quick response times right away. So the API request doesn't have to wait for all the actions to happen. We can just queue the message, we're good to go, it'll return our 200 response. And then it also gives us retryability. And so if something happens, some failure, some error writing, it'll retry that and let it go through. So the first stage is going to be writing to the cache. And so when the post comes through, uploads video, it's going to look for a batch of followers to write to cache, say like the first 50. It's going to do a push and then a trim on the home timeline list for those followers. And then as soon as it's done with that, it's going to queue a message to then propagate that right to our permanent data store in Mongo that we use at Hudl. And so that's going to be another queue message. And then it's going to queue another one to do the next batch. It's just going to continue this process until it goes through however many followers a user might have. And so the nice thing we have set up here with having the cache writes versus DB writes separate is caches is way faster, orders of magnitude larger, quicker than a Mongo write is going to take. And so by separating this out, we can go through all of those followers and get the cache updated and in sync with what we want the database to be eventually, within a matter of seconds, maybe a minute if it's a lot of followers. But as soon as that cache is updated, then on the consumer side, so then LeBron James has his phone, he's doing a pull to refresh. As soon as he tries to view that new content, it's going to go to the consumer. We're going to do some logic to see, does the cache already exist? We have some logic built in place to only cache timelines for users who have viewed it within 28 days. Because our traffic is so seasonal, we don't want to continue to cache people's timelines if they are not going to come back to Hudl for months at a time. But let's say it exists in cache. As soon as that first operation is through and written, they'll have access to view it, they can interact with it, they can share it, they can watch it, whatever they want to do. And then obviously if it misses, we'll just go to Mongo, pull it, and then cache it in for the next user. So pretty basic, but that's kind of how the flow works with our Redis and Mongo. Okay, so we're here talking about Redis, so I want to kind of focus on our Redis implementation. So at Hudl, we are a Microsoft shop. We love Microsoft, we love Visual Studio, love C#. So we took a look at what are the options available for C# developers to work with Redis. There's a couple different ones. Microsoft has one, ServiceTac has one. We kind of tried all of them out to see which one we liked the best, and we ended up landing on Stack Exchange, written by the Stack Overflow guys. It's got a pretty active community, and they keep up with features on Redis pretty fast. And so we've been happy with it. It did not take more than probably 10 minutes. Download the package, create a connection, and then you're hitting your Redis connection and testing things out right away. But one of the reasons why we want to go to Redis in the first place is that data type support and structured data. And so there's 3 different types that we use in our feed implementation. We use actually more now across Hudl other services, but I'll just kind of focus on these 3 for this talk. So the first is lists. And so I mentioned we have that operation we're going through adding to timelines. So timelines are all just lists in Redis. And so the great thing there is Redis makes it easy to just do a push and a trim, and we can easily get those lists in sync with what our database is going to be without having to have to invalidate cache and pull from database going forward. So we love that about it. The next use case we had is hashes. And so each user object has a number of properties. They're going to have name, email, a profile picture. They're going to have some properties that are counts, which are interesting. You may have like a follower count, a friend count. We don't want to be hitting the database every time to get those counts and compute them. And so we'll store those as hash fields on the user object. And then what's great is that with Redis then, as soon as you get more followers or you start following more people, we can just do an increment on that field directly without having to do a separate cache key or invalidate that and then go back to Mongo to get that data. So we love that a lot with hashes. And then the last one here is with sets. And so I mentioned with our queuing framework, we have that retryability built into it. But the problem is those actions are idempotent. They're not. And so if we don't have some kind of duplicate detection, the problem is, let's say you're doing a batch of 50 users to add a timeline, and the 49th one has an error somehow. Well, if it retries that again, those first 48 users are going to get the same post twice. Not a great experience to have the same post twice. So what we'll do is we'll create a set key based on the post ID, and then each user's ID that we're going to go to the timeline will be a set key value. And so then as we go through those users and followers, we'll check to see does the set already have the value. If it does, we'll skip it. If it doesn't, we're going to add it to their timeline. And so that's how we kind of protect ourselves there. So the next step was, okay, we like Redis, it's working well, how do we want to go to production? And so at Hudl, one of our core values too is making squads autonomous and removing dependencies and blockers and requiring other roles on squads. We want them to be nimble and move fast. And so we always look for hosted solutions as much as possible and managed solutions. And so at Hudl, we use Amazon really across the board for web services. And so we looked to see if they had an offering. They did, ElastiCache. And so we tried it out. We're really impressed. Really within 5 minutes, we could have a cluster up and running and testing with on our test environments. And we're able to kind of prove a proof of concept that this is going to be the solution we want to go with down the road. And so what's nice about ElastiCache on a production environment is you get a lot of niceties you get in other AWS services kind of for free. You get the high availability, you get read replicas, you get security if you're using a VPC, and then the ability to kind of pick and choose what version of Redis you want to run. So at the time we launched, we were running 2.8, and that was the most recent at that time. We were also running the 4x large, and everything was going great. Traffic was good, we were happy, it was live on production. And then 2016 happened, and we had a problem. We had more teams using Hudl, we had more users, we had more content in the feed, we had more people accessing it. These are all great problems to have for companies, but the data wasn't scaling as well. We were running out of space in our cache node. We really couldn't go much higher. We were already kind of at the highest node possible, so we needed a solution. And so we moved to a clustered Redis deployment, and that gave us the ability then to really scale horizontally as much as we wanted and as much data as we needed going forward. As far as the implementation to it, it really was not much code changes required. If you've used Redis cluster, you'll know that there's some things you have to know with multiple gets. So if you're doing like multiple keys in a single request, you have to be smart about how you're going to query those out across the different nodes and be smart about that. And then also taking advantage of hashtags where you can. And so if we cache different things by user ID or team ID, we can limit the number of nodes we have to go query from. If we're going to grab all the posts from a certain team, we don't have to go across multiple shards to get that data. And so that was helpful for us. During the actual upgrade, I'll just kind of talk about this, but what we ended up doing was actually having both the single node cluster and the Redis clustered deployment living side by side. And then we had just a config, we just flipped to route traffic to the new one. And then once we were confident and happy with everything being stable, we just took the old one offline. And so right now we're running 3 shards of 2x large. I fully expect probably to go to at least 4 this coming football season when traffic ramps up again. But what's great is it's just no problem to scale as much as we need to going forward. Okay, so now we're live in production. How are we making sure things aren't on fire? Things aren't breaking. There's essentially 3 metrics we like to look at with Redis. So we look at current connections. What if a node drops out? What do we need to do to get it back online? Route traffic to another node. Kind of a basic one there. Freeable memory. This is an interesting one. If freeable memory is dropping, we want to at least ask ourselves some questions about why is that happening? Is it because some developers started adding new data to a cache or caching new types of data? Do developers change how big lists are getting, and so we're running out of space there? Are our expiration dates on our cache correct? Do we need to maybe think about making them shorter, making them longer? We can look at the cache rates, the cache hits, the misses, but it just forces us to ask those questions to see if we need to make changes. Or maybe the problem is we're doing everything right, we just need to add more shards and get more space to scale. And then the last one here is swap usage. So when Redis gets full and runs out of memory, it's going to have to do swapping to move data to disk, to make space to move things around. And so when you're using Redis as a cache entirely, focusing on swap usage is important to make sure that it has the space it needs to keep evicting data and doesn't end up doing a failover and having downtime degraded service for you. And then also I will say with ElastiCache, you get out of the box Amazon CloudWatch to get all the monitoring you can use on top of that. This is what I pulled this from. We also internally use SignalFX, and we used to use Stackdriver, and both of those integrate with CloudWatch, and so you can get your alerting set up that way if you're interested. Okay, so let's look at some performance metrics. So we've been running now for 2 full years. I pulled these numbers from last season, football season. We were running at that time 27 million items in the cache. The get timeline request, so this is kind of like the most critical path for our users. This is when they're landing on the home page, they're logging in, they're logging into the apps, and they're getting that feed. We want that to be as fast as possible. And so these times are actually including network latency into account as well. So what we saw is the 50th percentile, 2 milliseconds, 90th, 4 milliseconds. So we're super excited about that. What's great too is it handles a pretty decent amount of load. During our peak usage, we were around 350,000 hits a minute. And you can see like as our users kind of vary by when they log in, log out for the day. And then just going back to like our use cases for users. So with a feed, the feed naturally is going to be a read-heavy operation. And so if you just look at like the network data, we're averaging about 10-to-1 ratio there for network data going out versus going in. And that's pretty typical for how the feed works. There we go. Okay, so some lessons learned, tips. I want this to be practical for you guys. If you are thinking about going to Redis, or if you have Redis in your production environment, things you can kind of take away from this talk. I would definitely recommend having dedicated instances per microservice. If you have that architecture at your company, it's just you never really know what data is going to be coming from other users, other services. If you have a shared instance, and they could potentially do some bad things, and you have to kind of protect yourself from that. And so having isolation there is important, and it kind of follows the whole microservice pattern in general. The next one is just updating your clients. It may seem trivial, but we've been burned before in the past where you get things live, it's working, it's looking great, and then you kind of just forget about it and let it go. Well, those clients like Stack Exchange, Redis, they're always making improvements, they're always doing performance changes, bug fixes, and so we've kind of had to force ourselves to get in the habit of maybe like once a month, look at the change log, see what they're fixing, do some testing, and roll out new versions to get enhancements as much as possible. So it's easy to forget, but it's really easy to do and can save you guys quite a bit of time. Pipelining is a concept of essentially queuing up a bunch of requests together and then waiting for them all to finish together instead of having to do each one synchronously. Whenever you're doing lots of transaction type stuff or a list of operations, I would highly recommend do that. It's one thing we found to have a big performance improvement at Hudl, is taking advantage of that. The great thing is our client for Stack Exchange Redis has two different ways of doing that. You can use their batch interface and queue up operations that way, or you can use just async await tasks and C#, and then wait them all together, and you'll take advantage of pipelining that way. Next tip is just like fail fast. When you're creating these connections, one thing we did initially is we had the sync timeout set to 2 seconds because we wanted to give Redis time to respond, and we wanted to be like resilient. We actually found that was like a really bad idea looking back, because what was happening then is if for whatever reason we had a socket failure or the connection timed out, something like that, users were having to wait a full 2 seconds to get that failure and try it again or fall back to the DB if we had to. And so we've rethought our approach now, and what we do is we look at what is the 90th percentile for our average requests, and we'll set our sync timeout at that, because then we want to fail as fast as possible so that users can then get the data from the DB if they have to, or a different node in Redis, but we don't want them sitting around waiting. The whole point of cache is to be fast, not slow. And then the last thing here is just with hashtags. So if you are using Redis cluster, take advantage of that where you can. Maybe you don't have a data model where you can use user IDs or team IDs, but thinking through, maybe you could use like regions or locales or locations, but some way of grouping together cached keys, so that way you're going to less shards to get that data back to your users. Local performance there. And then the last one here I mentioned is just a Redis setting that we did not take advantage of the first year that actually kind of bit us in the butt. So when you're using Redis as a cache primarily, by default, it's going to consume whatever the max memory value is and fill up that server. And so what the reserved memory does is it essentially says, okay, the max memory for this server is, say, 20 gigs, but I want to set aside maybe 2 gigs to use for evictions and moving data around and doing replications. And so we didn't have that set initially, and what was happening was our nodes were getting so full of data, and on busy days or busy weekends we'd get full, it would actually trigger a failover because so much swap usage was happening, and the server couldn't handle it. And so if you're using Redis as a cache entirely, I would highly recommend looking at this setting. We found around 10% is about enough you have to keep things in tip-top shape, but definitely something to look into. So just quick update about Hudl and going forward with Redis. I've been really impressed at how quickly the teams have adopted Redis. At Hudl, our general practice is we let teams try whatever they want. If they want to use new technology, they want to experiment, they're welcome to. And then really, the adoption rate kind of depended on how people perceive it. If people like the technology and more teams are using it, then it's going to become the de facto standard because it's just winning. And with Redis, we're seeing that. We're seeing that as people learn about Redis, experiment with it, try around with it, everyone has been moving forward on their production deployments. And so here's some services here I fully expect within the next few years to be entirely on Redis as much as we can. We're really excited about it. One thing we're still thinking about doing is figuring out where we could potentially use Redis as a permanent data store. So we still use Mongo and SQL in some places to do our permanent data store, but after hearing more talks and hearing more ideas around Redis, I think we're open to the idea of possibly moving some of our services to Redis entirely. And we think we can get even faster speeds down the road. And with that, I just want to thank you. Thank you, guys. Any questions?
Hi. So do you do any sort of filtering or processing on the feed, or is it just like all events from everybody you follow?
Yeah, so we don't actually do any filtering. We've talked about possibly changing the scoring of recent posts, so like that way you can bump up ones that are getting more traction and more views, that kind of stuff, but currently we don't. It's something we're thinking about in the future, but not right now.
In the architecture diagram, you showed that you write to the database, I think it was like Mongo or something, after Redis, like it goes through another queue. Are you assigning like a unique ID somewhere earlier on that you're able to do like pipelining with, or are you using like Lua scripts to like make the, you know, all the things you need to set in Redis like happen and link to each other?
Yep, so I didn't show this on the architecture graph, but there's actually another step before the cache writes where we actually save that post and generate the post ID. And then what we're actually caching is that post ID on the timelines. And then when we pull the timelines on like the feed and loading, whatever, we'll just hydrate those from a different cached object entirely.
Instead of using list as a feed and then set to avoid the duplicates in the feed, can you use sorted set as a feed, and the weightage maybe is a timestamp. You can use timestamp as a weightage so that the newest item always come on the top, and the duplication is taken care of by Redis itself.
Yeah, that's a good idea. We haven't tried that out, but that might work.
Could you elaborate a bit more on using hashtags? So we use them like whenever we're doing Lua scripts, we need all, multiple keys that the scripts are going to operate on. But otherwise, we've always kind of strived to spread the load across the cluster. So you're kind of saying the reverse, that you'll get better performance by pushing everything to a node. And we were under the impression we could spread the reads across, different nodes. Yep. Yeah. So our use case here is like, let's say someone's going to your profile and looking at your posts. All those posts are going to be like created by you as a user. And so if you have the hashtag as like your user ID, you can get all those posts loaded from a single shard directly. And if you have enough users and you assume like random distribution of people who post a lot, people who post a little bit, it should be pretty evenly distributed across your shards.
Have you had to deal with hotkeys, and how have you dealt with those, if you have?
We have not had to. We've not had a problem with that to date. I don't want to say it's not going to happen. I mean, hearing other talks talk about it was helpful to know about and think about, but not a problem so far.
So when you do the writes to Redis, if they've not been on the site for 28 days, you say you don't cache. So does it check for the key to see if it's there before adding it?
Yep, correct. I didn't touch on that, but yeah, we will check to see if the key is actually there. So yeah, so like if you have millions of followers, most of them probably haven't been on the site for a while. So if they haven't been on the site for a while, we just don't write to that list.
Okay.
All right, thanks, Joel.
Thanks.